stopped. It said some reason not recording anymore. I was like, great. Okay. Yay, Gary! Guys, we should be proud of our classmate, Gary. He got his 3-ring binder. We're super proud of you. Okay, don't forget, pink pages in the front. More pink pages coming at you this week. Just good resources for you, all right? Just for you to keep in your backpack, in your binder. All right, so it's going to take some getting used to. My turn. It's going to take some getting used to. And like I said on Friday, I think it was this class, I'm still figuring out the best way to stay organized and help you be organized, because that's really what this is about. We've all got the binders. Excellent. Keep everything in there. Don't lose that binder, okay? And I don't know. Remember, I have tons of sticky notes over there, and you're welcome to as many as you need and want. But if it might help to like tab where we just left off, so you're not constantly looking, because there's a lot of paper and there's a lot more coming, okay? Because that's only up through a certain part of this unit. There's 9 units, and you have like half of 4, up through 4, okay? So let's keep helping each other get organized and stuff, and I'm still coming up with ways to kind of suggest to you and stuff like that. Because remember, the notebook is yours, but think about how you can make your life easier. Maybe, like I said. Okay, I already said it. Well, I don't know. I keep talking about it. Let's go. All right, so we're on, remember, she does 1A, 1B. I call it day 1, day 2. It doesn't matter. Just know where we are, okay? And so we're still doing change in tandem. And I didn't really talk about tandem on Friday, but change, we know what change means. And tandem means like how one thing changes, how does the other thing change? Like in our case, it's like 2 things, X and Y. You know, we're talking about these graphs, which are made up of points that are X's and Y's, and what all the different things, properties we could pull off the graph. So on Friday, we did domain and range, and we did increasing and decreasing. We're going to introduce today concavity and inflection points. So just more and more stuff that we can pull off the graph. And we're not even done, okay? There's tons in this unit of looking at graphs and identifying important information, okay? So an inflection point, this is new, okay? You probably haven't seen this before, is where a curve changes from concave up to concave down, or the other way around. So, you know, as it goes up and down, where is that point where it changes? Okay, that's called an inflection point or point of inflection. Okay, we say that you have to be in calculus, which we're not in. Right now, we're pre-calculus, to algebraically find that exact point where a curve goes from up to down. We are mostly going to do it by looking at a picture. Okay, someday you're going to be able to take something like this and find its second derivative to find your inflection points, but that's not till next year if you go to calculus, okay? So we're doing it a little bit simpler, which I'll show you in a second. The other idea are these 2 pictures. Concave up, you guys might remember like when you graphed quadratics, which are known as parabolas when you graph them. Concave up looked like this, okay? Concave down looked like this. These are very straightforward graphs. You have one, you know, concave up or concave down. In a minute, we'll be seeing where you could have multiple ups and downs depending on how the graph curves, okay? And concave up and concave down, we say that the slope is doing something, okay? Slope is also rate of change. That is kind of used more often. So I just want you guys to know when you hear rate of change, it's the same as slope, okay? So you can say either one. They mean the same thing for both of these, rate of change and slope, how the graph changes. And your slope is increasing, we're concave up. If your slope is decreasing, it's concave down. That doesn't mean positive or negative. It literally means the numbers. Like 1/2 is less than 2. So if we go from a slope of 1/2 to a slope of 2, that's increasing. You know that it's going to be concave up. If we have a slope of 2 and then a slope of 1/2 in that order, 2 to 1/2 going left to right on a graph, that would be decreasing. So that's what that is referring to, okay? So looking at this graph of g of x, we're going to pull out these new pieces of information. So I'm just going to use some colored pens to kind of help you see. So let's just talk about what we talked about on Friday, increasing and decreasing. Not slope increasing or decreasing, that's different. Just how the graph is increasing and decreasing. Probably the most basic concept of a graph. Is it going down or is it going up, right? So this is going decreasing, then we switch to increasing, decreasing, increasing, okay? And we named those intervals on Friday according to the x-axis. We're going to do the same thing for concave up and concave down. We still use, whenever it talks about the intervals, that's intervals of the x-axis. So concave up and concave down. So I'm hoping you guys can agree with me that this piece of the graph right here is concave up. And it only goes to here. That's where it stops being concave up. Because doesn't it switch right there? Now it's going to be concave down. This is tricky right here. Does it stop at 3 or 4 x value for concave down? 3. Probably figured it out because I stopped there. But you can't keep going because actually, look at the color. When I put it in colors, I think it's easier to see. That's actually concave up right there. Okay? So the way we are going to do this is just name those intervals of the x-axis, just like we did on Friday. And if you remember increasing and decreasing, I said you can use parentheses, you can use brackets, it doesn't matter. For concavity, it matters. We use parentheses. Okay? Parentheses to name our intervals, not brackets. So concave up, what part of the x-axis is my red graph? So think about it. This arrow, as it goes up, it's going to the left forever. So we're going to use all of the numbers to the left. And we're still concave up, concave up, concave up. And then we switch right here. That x value is negative 0.5. Okay, that's the part that's concave up. We also have this part over here that's concave up. From 3, remember the x-axis, to what? 3 to what? Positive infinity, right. There's no rule about putting an and, an or, a union symbol, comma, just you're listing them. So you might see somebody put a union symbol there, might write the word and, might write the word or, might put a comma, same as increasing and decreasing, it doesn't matter. Okay? Now concave down from here to here. Remember, just the x-axis numbers is negative 0.5. Sometimes I put the 0, sometimes I don't. To 3. And this is going to take some getting used to, seeing those pieces of the graph. It actually took me a while to really get comfortable with the visual of it. Doing the different colors kind of helps. And actually, like when you even just trace it, like when is my pen going to start going the other direction, where I'm just going up and then turning, okay? And points of inflection, you will see me write, all of us write POI. We're all about abbreviations in this class. Let's make it nice and easy. We don't have to write the whole words out. Is where those changes happen. So we have a POI, that's an arrow. That's a POI, and that 3-1 is a POI. Okay, so we can just name them. And these are points. Think about what a point is. A point is an ordered pair. You never would use brackets on an ordered pair, like an X and a Y. So these are just regular old points. What is the point of inflection? Negative 0.5 and negative 3. And we have another point of inflection at 3, 1. Okay? There is a trick to knowing how many POIs there are. And I'm going to write that here for you. Because you have a homework problem, that all it asks for is how many points of inflections are on the graph. It doesn't ask you to name them or anything. And there's just a nice, easy way of knowing how many POIs. It's the number of turns minus 1. So if I just trace this, okay, here I go. I change from decreasing to increasing down at this point. So there's a turn 1. There's a turn 2. There's a turn 3. There are 3 turning points on this graph. 1, 2, 3, like the highest and the lowest. And if you subtract 1, you get 2. That's how we had 2 points of inflection. So if there's 5 turning points, you have 4 points of inflection. So it's a nice, easy way to kind of make sure you got it right. You won't miss any. Okay. Now, remember I said, without a graph, if I asked you, what is the point of inflection or inflections of this graph, of this function, we would have to use something called a second derivative in calculus to find it, okay? But we're not there, so we're doing visual ones. We're looking at a graph. And if you look at this graph here, we're increasing turn, decreasing turn, increasing, 2 turning points, 1 point of inflection. It's not named. It's going to be somewhere in between these 2 points though, right? Because look, I'm concave down here. And then I change at this point right here. That is my POI. But notice she didn't name it for us. It's not given the ordered pair like the picture above. And then we switch to concave up. Look, this is where it's going up. It's not perfect like a parabola, like equal on both sides. That's what's kind of tricky about it. I think all of you, if I gave you these and I said which one's up and which one's down, you would all get it right. Concave up, concave down. It's harder to see it when it's like adjoined to another part of the graph. So how do we name that point when they're not given to us? I mean, we could estimate it, right? We could estimate, but there's a little bit more of an exact way of doing it, and that's this point A. If we find the average between the high point and the low point to determine approximate value for the x-coordinate. So for part A, all it's asking for is, on this point of inflection, what is the x value? And we can use just some really, really simple math that we've learned before and find the average of the high point and the low point's x value. So when you find the average, like if I said average out your homework grades, you add all 10 of them up, for example, and you divide by what? Amount that you have. So if there's 10 homework, you divide by 10. We have 2 x values, we'll divide by 2. So let's just add them together. Doesn't matter which one goes first, which one goes second. And we're going to estimate that that x value is at approximately -1/2, or you could write 0.5. Either way. Doesn't matter. Okay? So that makes sense, right? We're counting by 1 on the x-axis, so 0. It looks about halfway between. So that makes sense. Okay? Part B is, now, how can we find the y value of that POI? Where? What? I was wondering why no one has asked me about that. I meant to check it last period. 16 plus -2. Is that? I got to see what the answer is. Um, 16 plus -11. You can do the same thing. Okay, so we can do the same thing and we can add those two together, but I was going to show you some other way too. 16 plus -11 divided by 2, and we get -5/2, or is it positive? Sorry, +5/2, or 2.5. So either one of those would be okay. You could also plug the x value in to that equation. You could have plugged -0.5 in here and here and done it all in your calculator and gotten the same answer, but this works as well. So we now know the x value and the y value, and that makes about sense, right? From 0 to 5, it's somewhere in between 0 and 5. 2.5 looks pretty good. It makes sense, okay? So that's a way of just estimating it on a graph if it's not named. What I mean by named is she gave us the ordered pair for that one and for that one. So the graphs, get used to it. There's a lot of graphs like this where you have to see, what is she meaning that ordered pair to be? Because they kind of get jumbled together. You'll see on the homework. You have to really look at the picture and see what's labeled. Okay. And the last part is state the intervals where we're concave up and concave down. So concave up, concave down. Write it out if you want to. I'm trying to find places where we don't have to write so much. So the intervals of concave up, concave down, just like we did up here, parentheses only. If we're going to do up, we already know the point of inflection. It's here. So that's going to break up the two parts, okay? So again, I'll do concave up in green. That would be from here to here. And even though you don't see arrows, guys, we're going to assume there's arrows on the ends of all the graphs unless it has a point, but showing it stops right there. Okay, because your graphing calculator screen never has arrows. Okay, when you graph on there, you won't see arrows. You just have to know, oh, it's going on and on. So we assume the same thing in a picture. Okay, so how do we name that? That's just the x values. We know that's from -0.5. We're always using parentheses for this. To what? Infinity. Yep, positive infinity. Yep, it goes to the right and up forever. And then concave down, it's this whole graph. We're assuming that arrow's there, so it goes on forever, down, and all of this is concave down. Look at it. It's like opening down from negative infinity to negative 0.5, or 1/2, doesn't matter. Okay? Good? All right, next page. We're going to do the examples on this page, and then we're done. So you might notice that there's an example 11. We're not doing it. It's lovely. It's just a lot of work. It's kind of putting everything together that I'm going over. So if you wanted to go back and practice that, you could, but you will see I'm not you doing it in the notes. So remember, we have a lot of paper, and there's many, many times we're crossing things out on these papers, just like in the homework and stuff, okay? So let's finish this page, and this first part, actually all of this is going to be pretty easy for you guys. Identifying intercepts, x-intercepts, y-intercepts. Intercepts are where the graph crosses each axis, okay? So x-intercepts are where you cross the x-axis, y-intercepts are where you cross the y-axis, and in each of these, one of the letters, the other letter, is 0, right? So for x-intercepts, we go left or right to find them, and we go up or down 0, right? And on the y-axis, we start at 0, 0. We don't go left or right at all, and then we go up and down depending on the y. So just remember that. 0 is one of the pieces of your ordered pair for all intercepts. And this first one, it's just visual. What are the x-intercepts? You just look at it and name it. Don't overthink it. It's just where does the graph touch the x-axis? So a couple different ways you can write it. You can list them, any order. You might see it look like that. That would be perfectly fine, right? Here, here, and here. You could write them as ordered pairs if you wanted to. You don't have to write both of these examples. I'm just showing you. But notice y would be 0 on all of those. Or you could write it as and I'm trying to get a lot of this stuff out of the way in the beginning of the course, because you'll see things written different ways, and I want you to be comfortable. Anyway, those are all 3 ways that you could have listed the x-intercepts. All 3 ways that you could see it on a multiple choice quiz or something, okay? So they all are saying the same thing, okay? These little fancy brackets are just like a solution set. Those are the answers to whatever question you just asked me, okay? And the same for the y-intercept. I'm just going to write it one way for this. The y-intercept would be -3. But again, you could write it one of those other ways. Let me just write it this way too, just to remind you about the 0. Okay, x would be 0. So pulling it off of a graph, easy peasy, right? Just knowing what to look for. How do we do it algebraically given a function? We factor. I told you factoring was not going to go away. It's going to pop up its little head throughout the year. And we see a problem like this, and we go, oh, I got this. If I don't, I can go back to my pink Algebra 2 review in my folder. But this is 4 terms. So whenever you have 4 terms, we do the grouping. So here's a review of that right now. Okay, so I'm going to factor out the GCF of the first 2 terms. Remember, sometimes it's a number, sometimes it's a letter, sometimes it's both. In this case, it's just a letter. X to the second is what they both have in common. And if it helps you to write it underneath, it's up to you. I don't normally write it. I'm just kind of making sure you guys know what we're doing here. We're dividing both of those terms by x squared. This is simply the reverse of the distributive property, because you can check this now using the distributive property. Okay? Then we can factor out a GCF in the back. And don't forget that anytime the third term is negative, your GCF is going to be negative. Don't forget that. That'll make the signs nice in the parentheses. And they both have a -4 in common. So I'm dividing both of these by -4. I will be left with x minus 3. And that's what we want. Remember, the parentheses to be the same. So the way we write this so far, remember, the identical twins would go in one set of parentheses. And then those GCFs, little hearts, would be x squared minus 4. Notice anything? Yeah. They sneak in on us. Most of the time, we're done at that point. But remember, these difference of squares are sneaky, and they pop up here and there. So I'm just going to bring the x minus 3 down and recognize this. Teach yourself to look for it. That's x plus 2, x minus 2. So that's completely factored. If this was the question, if it said just factor, we'd be done. There's 3 factors. But it asks for the x-intercepts. Those are also known as the solutions, the zeros. There's lots of words for them. And if you remember, to find x-intercepts, y would have to be 0. And f of x is just y. That's what this is. So I'm going to plug in a 0 for y, also known as f of x. Why did I put it over there? Because I wanted to. Doesn't matter. You can put the equal sign in the front or the back. Same thing. And so 0 equals all of these. This is when you can set each of these equal to 0 and solve it and get your 3 solutions, written any way you want. And I don't need to see that work. If I set x minus 3 equal to 0, I would add 3 to the other side. I would get 3. I would get negative 2. And I would get 2. Okay. Does that make sense? Where'd I lose you? Sabine, you're good? Gary, did I lose you? Question? Some people have weird looks on their faces. I don't know if it's just you hate this or you are confused. Okay? Okay, so understand, I just set these equal to 0. So if you missed that, it's just, I'm doing this in my head. X minus 3 set equal to 0, adding 3 gives me 3. I'm just not showing the work, and I don't require you to either. And, what? Oh, no, 2 different problems. Yep, these are different. You won't get the same answers. How do we find the y-intercept? So what is the x value going to be when we're trying to find the y-intercept? 0. So when you make all of your x's 0, this is a 0, this will become a 0, this becomes a 0, right? Because anything times 0 is going to be 0. So this is 0 plus 0 plus 0 plus 12, which is 12. Y equals 12. It's all about the zeros. Plug in 0 for x to get the y-intercept. You could plug in 0 for y to get the x-intercept. The x-intercepts are harder. You have to factor it down before you can set it equal to 0. Okay? Factoring. Almost done, my dears. This might be reminiscent of Algebra 1, which seems like forever ago probably for you guys. But let me read to you. I'm happy to come explain to you when I'm done if you need help. All right, Tina is a sales clerk somewhere, and she earns $325 base pay plus $18 for each item sold. Okay, express her gross salary. Just so you know, gross salary simply means how much before taxes and stuff taken out. Just your straight up paycheck before the government takes your money. Okay, so express her gross salary, G, as a function of the number X items sold. Find her gross pay if she sells 24 items. Okay, so they're telling us to express her gross salary as G of X. That's what that means. So that's telling us how to start it. And this is just like a linear equation. Like you have a y-intercept of 325 and an 18 is your slope. So she gets $325 no matter what, and then $18 times the number of items sold. And you could have written it either way. It's addition, so it doesn't matter. So there's the express part. Express the function. But now we want to know what would G be when X is 24, right? How much is she going to make if she sells 24 items? So, like we've already done in our short math relationship together, plug in X value everywhere you see an X and put it in your calculator and get your final answer. So when X is 24, G of X, known as Y, is $700 and something. $57. $757 is how much she would make. Okay, so I just did that in my calculator. 18 times 24 plus 325. $757. Okay? Last one. If your pre-calculus book is dropped from a height of 45 feet on the planet Newton, its height in feet after 2 seconds is approximately represented by this, right? How long does it take for the book to hit the surface of the planet? So they're giving us the function. That 45 is already built in there, so it's kind of extraneous information. Don't let it distract you. You don't need that 45. It's in here. The question, so h of t is your height in how many seconds? Height in seconds. The question is how long? That's t. We're trying to find how many seconds does it take for the book to hit the surface. That is your h of t. That's your height. So if you're dropping your book to the surface, you're dropping it from 45 feet up, the surface would be how many feet? 0, right? So we're just going to put a 0 in for h of t and solve for t. You could have put the 0 on this side, or you could have put 0 on the other side. It doesn't matter, okay? In fact, I would have preferred it on the other side, but I already wrote it, so who cares? All right, I'm going to subtract 45 from both sides. Again, I don't need to see every bit of your work. If I model it where I skip a step in class, then you can skip the step in your homework and on a test. So I don't need to see every step of an equation. I hope you guys can do that without showing your work. Are you allowed to show your work? Of course. Some of you are perfectionists and are going to show every single step, and that's okay too. Then I'm going to divide by negative 14. And a negative divided by a negative is going to be positive, so I know my answer is going to be positive here. So when I put this in my calculator, I would get negative 45 divided by negative 14, and I get this yucky decimal. Ooh, I don't want a decimal like that. I'm going to change it to a fraction. And I'm going to hit math, enter, enter. And look, it just gives us the same fraction back. It's because it can't be simplified. So I'm going to use that number, 45 14ths. But we're not done because we want t, not t squared. So we'll take the square root. Okay. Now let me show you a trick. Let's put our radical on our screen, second square root. So put your radical on there. So second x squared is right here. And you can type in 45 divided by 14. It's not hard, right? But I want to show you a trick that you probably didn't even know your scientific calculators have this trick. It's super useful in this class. If you look above your negative button, it's got 3 letters, A, N, S. That means answer, okay? And what it can do, it'll take the most recent answer on your screen. So for us, it's 45 14ths, and it puts it where your cursor is. So it's copy, paste, cut, paste, or copy. Yeah, copy. Be more, but it's blue. So ANS is blue, so I have to hit my blue button to access it. And it will literally just say ANS there. So you just know that the calculator's brain is putting that 45 14ths there. And that's helpful when we, like, if you had not changed it to a fraction, you could have done it at this step too. Because the calculator knows all those digits forever. So it knows to put it all in there. But it doesn't matter. So either one, and you hit enter. Oh, I don't like that. Let's hit math, enter, enter. If you hit math, enter, enter, and it doesn't change it, it's because it can't be written as a fraction. That's the only answer. And it makes sense. This is seconds. It's taking almost 2 seconds for it to drop 45 feet. For us, we're going to round to 3 decimal places, okay? So that would be 1.793. The 8 tells the 2 to go up. That's seconds, okay? On the AP exam, everything tells you to round to 3 places. So we're just going to get in the habit of doing it in this class so that we are fine on the AP exam, 3 decimal places. Now, usually someone asks this question. Go. Okay, I was waiting for it. So yes, technically, when you take the square root of something, we would have plus or minus the 45 14ths. Why did I not even bother with the negative of this one, Steen? No negative time, no negative seconds. So a lot of times in word problems, we throw away that negative answer. But yes, if this was not a word problem, just solve, you would 100% put a plus or minus in front. So really good job. So that would be your final answer. Approximately 1.793 seconds is how long it would take. Okay? Any other questions? All right. So like I said, example 11 is the next page. We're not doing it, right, together, but if you want to, you can. Then I think if you keep turning your pages, you get to practice set 1, which is what we did on Friday. Keep going. I know. I'm not loving all the paper. It's a little confusing, but we'll get used to it together. remember, that says A6 if you can't see it. Please write the assignment down now. That way I can zoom in on the key and let you guys go. So this is your assignment. Please write it now. 17 through 23, 28, 29. There's plenty more to do. Don't do more than you have to do unless you want to, of course. Okay? And you guys are going to work at different paces. Let me just tell you something about number 22. You do not have to find max and min, so you can cross those out when you get to it. It was too much to write in the directions. I just figured when you got to the key, you'd see. We'll get to minimum and maximum in another lesson. I don't know why she put it in here. Unnecessary. Okay? So, everybody have the assignment written down? A6. Label, label, label. A6, A6. Good? Okay. I will come around and check on y'all. Thank you for waiting.